your competition between or what I think is competition, SpaceX and other companies out there, aerospace companies and space stations alike. So.
Okay, so first question, schooling-wise with NASA. So they don't help with undergrad too much, but you do get paid internships. So even the high school internships are paid internships, which is nice. And then they are paid pathways internships. And then when you graduate from undergrad, they do have programs in place to help you get your master's or your PhD if you're looking to do that. So they have programs where you can partner with NASA through your PhD and work your stuff that you're working on at work counts as your PhD work. So there are ways to pair it like that. So they can help that way. Or they will pay for you to take master's classes and stuff like that. Or if you're an undergrad and you're working in a different field, so I'm electrical, but say I need to do some mechanical things, they might pay for you to go take a class in mechanical so you can be better at your job that way. And then in terms of competition with SpaceX, we're really trying to work together. We don't want to see it just as a competition. We have a bunch of industry partners. About half of NASA is contracted other companies. So we're really trying to work together to get something going here for Mars. Other questions?
So you said that it takes, 17 minutes for communication from here to Mars. Are you working on ways to get that communication from here to there faster? And if so, how is that going to happen?
Yes, they are working on it. I am not specifically working on it. There's probably people at Glenn working on it. We have a big communications division. Basically, how that happened, we need to improve satellite technology. That's the biggest thing, is our satellite technology, how we communicate out there. We'd have to set up something at Mars, maybe, so make it communication better over there, too, so we could have a two-way street there. I can't speak specifically to it, because I don't do it, but I know we are working on it. Other questions?
I'm asking again. I heard about that big telescope thing.
The James Webb Telescope?
Yeah, the one that's getting sound out in space so you can see further. I want to know about that.
You want to know about that? I can work on that. Yeah, I know we've had some delays. We're working on getting it launched. Honestly, I'm not on that project. NASA's so big. I mean, we have 3,000 people just at Glenn, and that's one center. And we have 10 centers, so that's at least 30,000 people. So I do not work on the telescope. I'm not the first NASA head. I'm sorry.
Okay, so you said that you're going to try to build a gateway to orbit the moon, right? Okay, so how do you know that it will be successful?
How do we know that we're successful? Well, we don't. I mean, we always hope that it will be. We put into place plans. We get lots of people working on it. It's not just one person. It's a whole team of people that have to work on it. There's lots of safety features. We have entire safety divisions at NASA to make sure that if anything goes wrong, anything breaks, that the astronauts wouldn't be hurt. And really, it's just a collaborative effort. The whole agency has to get on board and work together to make sure that it will be successful. Other questions?
I have a question for you. Okay, so like when I went to this talk before I went to the school, they were saying like the strongest person that it goes to Mars is supposed to like die on the trip there. But I don't really understand that. Or is that true?
I am not sure if that's true. Like I said, Mars is pretty far off, so we haven't gotten to that quite yet. I know it's possible. I have heard it also before, that there wouldn't be a return trip for the first time, but I think we're trying to work so that we could get that. But I'm not sure specifically. I would get something else. There's a question. Question in the back.
What is so hard about getting a lot of energy into a small place?
The biggest thing is heat. So energy, there's a lot of current. Current means heat. Electronics are usually rated to about 155 degrees Celsius, which sounds like a lot, but when the part's the size of a speck of dust, it can get that hot very quickly. So current flows through all these electronics, and the electrons moving that fast builds up heat. And so more power means they're flowing faster and there's more of them, and that builds up heat, and the electronics will break if it gets too hot. So you have to figure out how to get rid of that heat in such a small area.
For the Gato project, so to go to the moon by Satellus rocket, it takes like 4 stages, right, to go to the moon. But after that, it takes command modules to see there, right? So how would you plan to build, like, assemble 2 more stages to build Mars? Like from Gateway to all the way to Mars?
So the same way we built the ISS, we would send up parts to build the gateway first, and then we would send up parts to build the unit that would go to Mars. So you have to send it up in stages, just like ISS. ISS was built in stages and chunks. It's the same way. We send up pieces at a time, working with commercial partners too, likely to get it all accomplished.